Uh, Hello everybody. So our project is building a car tracks communication framework for autonomous cars with Wi-Fi car tracing and traffic control optimizing. So here we built a car tracks communication framework which implements two things. One is Wi-Fi localization and the other is communication between car and infrastructure. Here we consider infrastructure to be traffic light. Let's see an overall picture of this framework. So we have developed this framework using Raspberry Pi. So we have totally three use cases. One is using a normal car, and the second one is using a special car without siren, and the third case is using a special car with siren. So how these cars can communicate with the traffic light? Let's see. So on the overall picture, the normal car, it uses the Google Maps API to find the latitude and longitude, which is then passed to the traffic light via server. So the server gets the information and it sends an optimized instruction to the traffic light. And the second case is special car, where the localization information is sent to the server and the special car can instruct the traffic light via server. And the third case is special car with siren, where we implement a message broker, and with the message broker, the special car can communicate and control the traffic light directly. Let's take a look on the first scenario, which is this special car with siren. Since it is a special car with siren, we consider this to be the highest priority case. So in the implementation, we have implemented this on a Raspberry Pi and we have implemented the traffic light on another Raspberry Pi. So let's see how does it work. So we have used a messaging protocol, which is MQTT, and we can have clients either subscribing or publishing on a topic on MQTT. So MQTT is basically a lightweight publish subscribe protocol which is used on top of TCP/IP. So here we assume the special car with siren to be the publisher. So whenever the location information is retrieved from the Google Map geolocation API, that information is published on a topic, and here we have the traffic light to be the subscriber. So when the subscriber subscribes to the same topic on which the special car with siren is publishing, then the traffic light is able to receive the location information directly. When the traffic light identifies this information is from a special car with siren, then the signal state of the traffic light is turned to green. So this implementation is done via LED. So I will show the implementation and the communication between the special car and the traffic light in my demo. Now I will hand it over to Chen for explaining the normal car scenario.
Hello, my name is Chenchen. I will explain you the server-based scenario, and this also will be a demo later. First, we can see we have three nodes. First node is a normal car. In the demo, it's a Raspberry Pi. Another one is server, which runs on my virtual machine. It's like a server on my Ubuntu. And the third node, called traffic light, is also run on Raspberry Pi. Then the first step, we collect the location information. This location information including home, mobile, country code, or IP address, or Wi-Fi access point. We mix this information together and collect them as much as possible. Then we call the Google Map geolocation API to process it. After that process, we get longitude and latitude, which is the location information. Then we send the location information to the server. Server will take care of with that information and give optimized instruction to the traffic lights. In the same time, the server also sends back the traffic lights instruction to the normal cards. So this is the server-based diagram of normal card. Let's say another diagram is this with special card. In the basic aspects, the special card also collects the information and send to the server. When the server receives the information from special card, that will recognize, oh, this is a special card. Then the server will directly generate a green light instruction to the traffic lights and directly control the traffic lights change to service for this special card. So this is the diagram, and you also will see this in my demo later. So, but this is only the overview of our projects. So in reports, we will give you all the detail on the screen diagram or other diagram together. Then you will see all the same in the reports and all the information within the our demo. So that's for our presentation.
Hello, this is Chen Chen. I will show you first demo. The first demo, we have three parts. One is a car, one is traffic light, another is a server. So the car also divided to two different types. One is normal car, another is special car. I built the communication between them and we can get the location from the car, then say to the server, then the server will get corresponding respond to the car or to the traffic light, which has been explained in the first part. Okay, let's go to the demo. Okay, we can see here first. In the right side, this is the remote control by TeamViewer. This control a Raspberry Pi in a car. And this one is another Raspberry Pi, also controlled by TeamViewer. This will be a traffic light. This one is running in the sensor lab, and this one is running here, my home, with this Raspberry Pi borrowed from my partner Ash. And the third part is our virtual machine. This is the server. This one will be the server. Okay, let's go say our demo. So in the first part, first we need to run our traffic light first. Then we run the traffic light first, waiting for signal. Then we run the server. Here we need the IP address because we don't have the fixed IP address. Every time we're doing the experiments with Analytica receive different IP address, so I need input my IP address as the input parameters. Okay, now we set up the traffic light. We set up our server. They're both waiting for the signal. Then we go to one car. This car called normal car. They will send information to a server. We can see here. We send information. We get our longitude and latitude and accuracy, and our IP address. The IP address is to the server. Then we can see here we received a green light is on, and for the server here we already have a window. It's generated by code. We can see here, this is my home, this is my car here, which is this Raspberry Pi, and we have another location is the traffic light, which locates on the sensor lab. And it's a command line of the server, which says we received the location data, this, and the car type is normal, the car IP is this, and this they send the traffic light signal back to our normal car. We can see here they receive the data green light is on. And for traffic lights, they will not change because this is normal car. It will not cause a change. So let's say another one. This is a special car, and the server is on, and our traffic light is on, so we don't to move them. So we run it. Okay, we can say here it says the location is this, and the information sent to server. Then in the server, it's my virtual machine. We can also say we run this in one Raspberry Pi, so the location is the same. And let's say the console. They said we received the location this, and car type is special, and car IP is this, and send traffic light signal to traffic light. Then we go to the traffic light. This is our traffic light in the sensor lab. Then we can say that received data, turn on x-axis green light for special car, and traffic light changed. For my part, I only implement the interface in the next demo done by Ash. She will tell you how to implement the traffic light change, because my Raspberry Pi is in a sensor lab. I cannot do this, but Ash will show you this on her devices. So this is all my demo. Thank you for watching.
Hello everybody. So you would have seen the demo from my partner Chen, where she would have showed the communication between normal car and traffic light, and special car without siren and traffic light. Now I am going to show the demo with special car with siren and the traffic light. So the difference between special car without siren and special car with siren is that we have used different kinds of communication mechanism. For special car without siren, a traditional UDP server client-based communication is used, whereas in this use case, that is the special car with siren, we are using a messaging protocol, MQTT, which is based on the publish-subscribe model via message broker. So let me show you the hardware that I am using for this demo. So I have a Raspberry Pi, which is the special card with siren, and I have another Raspberry Pi, which is the traffic light. It is connected to the LED interface via a breadboard. So this can be used to show the status of the traffic signal. So let us go to the demo. So here we have the traffic light, which is the subscriber. So it subscribes to receive the location information from the publisher. So the publisher here is a special car which publishes its location information to the message broker, and the message broker delivers this information to the subscriber. So the communication always happens via a message broker. So let me show how to execute our code. So now I am running the subscriber, which is the traffic light. So when I run this code, it waits to receive the location information from the special car, and the red signal is set on for the traffic light. And you could see that the traffic light is waiting to receive the location information from the special car with siren. And now I go to the special car with siren GUI, which is this Raspberry Pi, and I try to execute this code. When I execute this code, you could see that the traffic signal is immediately changed to green color, and you could also see from the screen that the location information is published from the special car to the traffic light. When you go to the traffic light GUI, you could see that the location information has been transmitted from the car to the traffic light, and the traffic light LED is still showing green because it is a special car, and the signal shade should be green for the special car. So I have run an algorithm to set the LED to be green for some time, and after the special car has passed by, the LED now changes to red signal state, and after some time the system is stopped. So you could see the location information is received by the traffic light. And thanks for watching the demo.